In this video, we will take a look at how we can create a pull to refresh experience using Rive in the Rive Flutter runtime. The animation that we will be incorporating is the following one. So as you can see, this is a pull to refresh experience, and as you drag down, it drives the animation forward. You can also let it go and it will reset. But eventually, if you reach a certain threshold, it will trigger a new state. And once you let go, it will start refreshing or doing the asynchronous request to load new data or whatever the pull to refresh does behind the scenes. But as you can see, it's a very unique experience, and we will be taking a look at how we can incorporate that in this video. If you are interested in how this animation is set up and how you can create something similar using the Rive editor, then we have dedicated tutorials teaching you exactly how to do that. In this video, we'll only be taking a look at the Flutter implementation. And if you're completely new to the Flutter runtime, then I recommend taking a look at our documentation. There is step-by-step instructions on how to get started with Rive on Flutter. Additionally, you will need to use the Rive Flutter package. And additionally, we'll also make use of the Easy Refresh package, as this was what will allow us to quickly create the pull to refresh experience and add our Rive animations. So with that said, let's just jump in and get started with the actual code. The first thing you'll need to do is open your pubspec.yaml file, and you'll need to include the following two dependencies, Rive and Easy Refresh. Please note that there may be breaking changes in future versions. If you want to follow this video exactly, I suggest using these versions listed here. Or alternatively, you can just get the final completed source code from GitHub. The link will be in the description. But note that we're not going to be walking through the code step by step, at least not me typing it out. Instead, I'm just going to explain it to you. So I do recommend getting the code or the final version on GitHub. Once you've added those dependencies, you can go over to the editor. So depending on the animation that you're using, you'll need to actually download it. So if you go to the share button here, download for runtime, you can download the .riv file, and this will allow you to include it in your Flutter project. I've already done that. So if you've not done that, you can just download it. And in your Flutter project, you can create an assets folder and just add the Rive file over there. Then be sure in your pubspec.yaml file, you'll need to include that file as well. You can either include the specific file by specifying the name, or you can include everything in the assets directory. Okay, so let's take a look at the actual code implementation. If we hop into my app, you can see we have a normal material app, we have some theming, and we return the archery page. And the archery page consists of the entire animation, or the entire view, I should say. So everything you see here is the archery page. And the important thing within this page is this is where we use the Easy Refresh package. And this allows us to do the pull to refresh experience. And as you can see, it consists of a controller, header, on refresh, and a child. And I do recommend you take a look at the Easy Refresh documentation. There's quite a lot you can do with it and a lot of customization that we won't be going into in this video. But what we need for our purposes are just these configurations. So let's first take a look at the child, and this is the content that's going to be displayed in the main body of the screen. So this will be the scrollable content. And what I mean by that, it's basically everything you see over here. And as we drag, you can see that all of that's scrollable. And if you are familiar with Flutter, you will be familiar with the custom scroll view. And this allows you to provide a variety of different slivers so that you can configure a more unique scroll experience instead of using a normal list builder. What do I mean by that? I mean that, as you can see, our scroll experience consists of a sliver app bar, this header locator that we'll get into in a moment, and then a sliver list. And this sliver list is a builder, and within this builder, we return a skeleton item. And the skeleton item is this UI configuration here. It's just for UI purposes to show a scrollable list item. And the custom scroll view allows you to actually have different kinds of scrollable widgets inside and nested. It's a more complex way of doing scrolling. And how the refresh package makes use of this easy refresh, they allow you to inject this header locator .sliver. And as you can see, it's between the sliver app bar and the sliver list. And as we scroll down, you can see that this is the location that we will be doing our Rive animation, or whatever you were to use in the easy refresh package. As an example, if we were to take this out and put it at the bottom, now if we scroll down, you can see the Rive animation is actually at the bottom. So that's not where we want it over here. So there's some unique ways that you can probably use this if you wanted to, but that is the overview for the body. Next up, you can see we have this on refresh, and this on refresh will be triggered once you hit the refresh threshold and you let go. So the refresh will be called right then. And we're just using this to drive the controller forward and to eventually call finish refresh on the controller. So this is just a simulation for what should look like if you were to actually load real data. And then the controller over here, this is the easy refresh controller. And again, there's a variety of different customizations you can do with this. And this is what drives the easy refresh animation. And it also allows you to determine what the current state is of the refresh. So with the overview out of the way, let's jump into the actual implementation with the Rive animation. As you can see, we have this header, and if we jump to this widget, it's called archery header, and it extends a header class. And you'll need to do this as the expected type is a header type in the widget. And what this allows is it gives you the indicator state.state. And this is needed in our example, as we'll see in a moment. So most of these are just initializations for the header class. And you can again take a look at the easy refresh documentation. But as I mentioned, there's a variety of different customizations you can do. These are just the configurations I chose for this example. Finally, if we take a look at the archery indicator, this is where the Rive animation is. And you can see this is a stateful widget. And we get the indicator state. And this indicator state is provided by this build method over here. And we use that state in a number of different ways. We use it to get the offset of the pull. So as you start pulling down, the offset increases. And also the current mode of the pull to refresh. For example, if we pull and reach certain conditions, the mode changes. And I think the best way to actually demo that is just to do a print over here. So as you can see, we have this listener called on mode change. And the on mode change is being triggered each time the notifier of the state changes. So this indicator state, it has this notifier, and what we want to do is add a listener to that. So each time this listener changes, we're just going to print the value of the mode. So let's see what that looks like. As you can see, once we start dragging, it says indicator mode drag, and eventually you'll see it's armed. Once it reaches the armed state, that is when we actually change the Rive animation. And then once we let go, it's ready, processing, processed, done, and then inactive. So those are the variety of different states you can use. And you can use these states to drive your animation or whatever you want it to do. And that is exactly what we do for the Rive animation. And we do that within this switch over here. So as we reach different states of the mode, we drive our Rive animation's state machine controller. And before we delve more into how this Rive animation state machine controller is set up and used, let's quickly go back to our Rive animation, and we'll need to explore how this works. And again, if you want to watch the video on how this is configured, I do recommend you watch that video. This is just going to be a quick overview. If we take a look at the Animate tab and we press play on the main artboard, we'll play it, and you'll see we have this two inputs. We have a pull and an advance. And for the pull, as you start increasing that value, it will eventually go to 100, and once it's more than 100, it will be ready. And now if we press advance, it will go into the refreshing state, and then advance again, it will be in the done state, and that's the end of the animation. So as you can see, that's how this particular animation is set up, and that is what we'll need to simulate in our Rive runtime. So going back to the code, what we'll need to do is we'll need to initialize our Rive animation and get access to the state machine controller. So let's see what happens in the build. Before we look at this, we're going to ignore this for now. And what we'll do instead is just take a look at the Rive animation over here. So ignore the rest, we're going to talk about that in a moment. As you can see, to initialize or to create a Rive animation, what we do is we call Rive animation.asset. And there's actually a number of different ways you can instantiate this. If you say .asset using that factory, you just provide the asset location, and then within the onNet, this is a callback that will give you access to the artboard. And the artboard that you will get access to is dependent on the default artboard of the file, or you can specify the name of the artboard. So as an example, this is the bullseye artboard, which is the default. So we don't need to specify it, but we can. And that seems like it's spelled correctly. So this should still be the exact same. Let's see if it works. Yeah, it's still the same. And we'll get access to this artboard in the onInit callback. And within this onInit, we can start creating our state machine controller. So we'll use a state machine controller from artboard, and we specify the artboard, and then we specify the controller's name. And as you can see, the name for this state machine controller is called number simulation, and we specify that name over there. Then we say controller is active equals false, and that is because we don't want the animation playing when it's not ready yet. Technically, this isn't needed, but you can include it because, yeah, I initially included this, but it's not really needed, and we'll see why in a moment. But what this means is the animation is currently paused. And then we're just doing a safety check. If the controller is null, we just throw an exception, unable to initialize state machine controller. This should never be null unless you give the incorrect name over here. So if we were to specify this, save, and actually run the animation, you'll see it throws an error. Unhandled exception, null exception, and you can read it over there. So let's just reset that. And then finally, we need to add the controller to the artboard. And we do that by calling the add controller method. So now what this means is that this controller can drive the artboard, or the artboard will respect whatever you tell this controller to do. As an example, whether the controller is active or not. And then lastly, we need to get access to two inputs. And these two inputs are pull and advance. And as you can see, we have these local state variables called pull and advance. One is an SMI number. This is called state machine input number, state machine input trigger. And a trigger is exactly that. It triggers an input, so trigger. And then a pull is a number value, and that is SMI number. And if we take a look, we get these values by calling find input, specifying the type, and then we just cast it to the correct value. And here it's important to also have the correct names. If you were to provide the incorrect name, then this cast will fail because it's trying to cast a null value. Finding an input can return null. So be sure these are the correct names. So that is excellent. Now that we have the controller and we have all of these values, that means we can drive our state machine through code. And that's actually quite easy to do now that we have all of the boilerplates out of the way. So let's see how we do that. Within the build, you can see that we make use of the pull SMI number, and this is what drives the value from 0 to 100. And as you can see, we just set the value equal to this percentage over here. And what this allows us to do is just determine how much we've dragged the value in relation to our desired offset. So what do I mean by that? It means that eventually, once you start dragging this, the value would be between 0 and 1.1. And the reason it's between 1.1 and not 1 is because we want it to be slightly more than 100. And that is because if we look at how this animation is configured, it will only trigger the next state. So when it's like the strain loop and it's like vibrating like this, if the value is more than 100. So we do want to make sure that it is at least slightly more. Probably doing 0.01 would also work. This is going to be dependent on your animation. And this is just something I had to do for this particular animation. But the important point is that we're setting the pull value between a value of 0 and something above 100. And then finally, if we take a look at this on mode change, this is again where we added that listener. We get access to the mode, and dependent on the mode, we start triggering the animation. So as you can see, when the mode is drag, we set the controller to be active equals to true. So that means we are actually starting the animation. And when it's ready, we fire the animation. And when it's processed, we fire it again. And that is just to drive it through the different states of that particular animation. This would look different if your state machine is configured in a different way. And previously I mentioned that this is active is technically not needed. And the reason for that is because there's this additional check that I added to only make the animation visible if the offset is greater than 0. And the reason I'm doing this is because if the animation is not visible, so for example, we haven't dragged it, we don't really want to be doing any unneeded work, so we don't want to be initializing the animation, and we definitely don't want to be drawing it when it's not even visible. So what this visibility check does, it makes sure that the animation will only become active once it should be active. As an example, if we were to increase this to 30, and now we drag, you can see the animation is not there, it's not visible, but eventually it will become visible. So we'll just keep it at above 0, and now it will be immediately visible when you drag. Though, one thing to consider is that with this implementation, as I mentioned, there's a variety of different factory constructors that allow you to instantiate a Rive animation. What this means is that the Rive file will be loaded, the artboard will be retrieved, and this initialization will take place every single time you do a drag like this. And in this instance, the animation is quite lightweight and it does it really fast, and you normally shouldn't see an issue. But if you want it to be, I guess, a 10x engineer and increase the reusability of what has already been done, you can preload your Rive file and just provide that. So let's actually see how we can do that. What we'll do is we'll uncomment this, include the services package, and in our net state, we will call this method. And what this method does is it loads the Rive file for us, and eventually, after it's loaded, we just create a new Rive file instance by importing the data that we loaded from the root bundle. And then we call setState, and this is a Rive file that can be null. And what we can do now is in our build method, we can say if the offset is bigger than 0, and we'll say Rive file not equal to 0, or not equal to null, sorry. And then instead of doing an asset, we can just say direct, and this requires us to actually pass in the Rive file. And we can add the exclamation because we know the Rive file won't be null. And now if we get our simulator back, we'll just need to do a hot refresh, a hot restart. And now it works the exact same way. The only difference is that we're not reloading the Rive file each time. We are instead pre-caching the Rive file and just reloading the artboard. And again, you don't technically need to do this visibility thing. You can keep it in the background and just running constantly if you wanted to, but it is a slight performance optimization that you can implement. Additionally, in this example, if we take a look at our animation, it is not configured to actually reset back to a certain state. So it reaches 100 and something, we press advance, and it's done. How do we go back to a clean state? And Michael, who made this animation, he would definitely be able to set it up in such a way, and you would be able to too, to set it up to rewind or reset the state machine back to a previous input. But what you can also do is just reload the whole animation. For example, stop it and play it again, and now it's reset. And in a similar way, that is what we're doing here. When we are recreating the artboard, we are essentially invalidating the old one and creating a new artboard. It's a clean state, and we can just start again. And that is that. That is how you can create an awesome pull to refresh experience using Flutter and Rive. We have a number of other tutorials as well, showing you how to do this in other platforms.